All right, another video on momentum and collisions. One thing worth noting right away is I have the equation for impulse. Impulse is the change in momentum. Change in momentum is mass times change in velocity, which is also equal to force times time. So if you think about that, change in velocity over time is acceleration, which is mass times acceleration is force. So force times time, yeah. Okay, so momentum equation, momentum is equal to mass times velocity. Pretty straightforward and simple. Two types of collisions, an elastic where bodies bounce off one another. A before and after equation would be m1v1 plus m2v2 is m1v1 prime plus m2v2 prime. The inelastic collision where bodies stick together like two train cars getting linked. So that means m1v1 plus m2v2 before is equal to m1 plus m2 connected times their V final. Okay, so in the special case where the original momentum is zero, don't forget that whatever the momentum was that started, it has to be the amount of momentum that you finish with because momentum is conserved. So if we have the example of a 50 kilogram boy sitting in a 75 kilogram boat, throws out a 5 kilogram box at 5 meters per second, what's the velocity of the boy and boat? Speed and direction. That means the momentum going left has to equal the momentum going right. So our right facing momentum then, that's the 0 equals momentum left minus momentum right. Okay, so that means 25 kilogram meters per second is equal to 125 V. So that means V is 0.2 meters per second west or to the left. Okay, so in a scenario where you have two objects about to collide, you got to determine if the collision is elastic or inelastic and how fast each of the masses is traveling. Carefully calculate the momentum of the entire system before the collision and set that equal to the momentum of the system after the collision. Remember that impulse is change in momentum. Now this is important that you understand this. If there's no collision about to occur in your before collision circumstances, in other words, if you looked at this picture and said, well, that's not moving yet, and that's not moving yet, so this is not moving yet, so this all must be zero. Well, if that's going to hold up, then this will not collide with that, so it's not a momentum problem. So make sure you understand that if there's no collision about to occur in the before scenario, like this has zero, this has zero, they're not going to hit. If this has zero, they're not going to meet. Well, then that's not a momentum equation. We're probably just looking for a free body diagram. Okay, just a reminder about impulse. Have fun.